Look, there's a seat right here next to me.
And I see that one next to this. One right there. Oh, I like your t-shirt. Right there. There's one next to her.
Okay, so we're gonna start with centroids on a graph. Centroid technically is the balancing point of a triangle. So if I pretend with my big brain that this is a triangle, because that makes sense. This is a triangle. Everybody knows that you could take technically any object, including this triangle, and you could technically put your finger somewhere at the bottom of it, and you could find the balancing point somewhere. If I could do it. I did it last period. See? Balancing point of a triangle. It's not triangle, but whatever. So we're going to find the balancing point of each of these triangles. This is technically tied back to chapter 1. It is very easy. So that's why we're doing 2 separate papers today. We're going to talk about orthocenters real quick, and then it's really just centroids. So centroids for this, we are going to use the midpoint formula from chapter 1. So it is on the formula sheet, which you don't have, but it's also on the wall over there. We're going to write the midpoint formula on our paper. So over here where it says examples, we're going to write the midpoint formula. Midpoint formula. Midpoint formula is from chapter 1. It's finding the middle of a line. So what we're going to do is we're going to take the x's, x1, and we're going to add it together with x2. And then you divide by 2. Beep. And then because it's a coordinate point, what you do with x, you also have to do with y. So we take the y's, y1, we add y2, and we divide by 2. So that's literally what we're doing today. This is from chapter 1. The only thing is a triangle is made up of 3 sides. So you have to do the midpoint formula 3 times. Realistically, you can just plug it into the calculator, which I'm totally fine with. So for this, what we're going to do is we are going to start just by writing out the coordinate points to this triangle. So let's start with K. K is at 10, 9. Where is J at on the graph? Negative 2, 5. And then L is at 4, negative 5. So it does not matter which side you start with. I'm just going to literally start with the first side, like JK, because that's the first 2 I wrote, just because. So basically I need to figure out where in the middle is the midpoint of JK. So I'm going to use these 2 coordinates, J and K, to find the midpoint. So I'm going to start with just writing JK or KJ. I'm going to take the X's. I'm going to add them together and I'm dividing by 2. So what's my 2 X values from J and K?
8.
Yes. 10 plus negative 2 divided by 2. 10 plus negative 2 is 8. 8 divided by 2 is 4. So I'm just going to literally write 4 down here. The next thing I'm going to do is I'm going to do the Y's. So I'm technically adding 9 and 5, and I'm dividing by 2. 14, which is 7. And that's what I mean by, like, you don't really need to write out the work. I'm going to show the work for the first one because it's an example. So when you look back, remember that technically they come together. One is X, one is Y. So we're going to plot that point. It should fall between J and K on that line. So 4, 1, 2, 3, 4, 5, 6, 7. So that is, oh geez. So that's my midpoint. And then we are going to make the median because a centroid is made from medians. We're going to connect the point, the midpoint, to the opposite vertice. So using your ruler that you grabbed or a protractor that you should have grabbed, because you should have grabbed one of them, we are going to connect that midpoint to the opposite vertice. So I'm not connecting it to J, not connecting it to K. I'm going to connect it to L, going straight down. Okay. We are going to do the same thing for one of the other sides. So I did K and J. Now let's use J and L. So we need to figure out in the middle, J and L somewhere in the middle. So if I look at these 2 points, let's look at the X values first. What 2 numbers are actually being added together? Perfect. -2 plus 4. -4 or -2 plus 4 is 2. 2 divided by 2 is 1. Perfect. We're going to do the same thing for the y's. We're taking the y's, we're adding them together. So what's my two y values? 5 and -5, which is 0. 0 divided by 2 is 0. So this is what I mean. You can literally just do this really in the calculator. We have another midpoint. I'm going to plot it. And then I'm going to connect it using a ruler to the opposite vertice. So 1, 0 is here. What point is that going to connect with? A, because it's the opposite vertice. We're going to do all 3 sides. So the last side is AL. So if I look at my x's, what two numbers are being added together? 10 and 4. If I add them in my brain, 7 or, well, yeah, 14. 14 divided by 2 is 7. My y's, I'm adding 9 and -5, which is 4. 4 divided by 2 is 2. So we're going to plot it. It should fall on the last side, and we're going to connect it to the opposite vertice. So the whole point of the centers is where the 3 lines, whatever 3 lines you're talking about, circumcenter is perpendicular bisectors, incenters is angle bisectors, a centroid is medians, orthocenter we haven't talked about yet. But where those 3 lines intersect is actually the center. So where's the center at? Where do these 3 lines cross at? At 4, 3. So my centroid is at 4, 3. And that's it. So technically, if this was actually like 3D printed or something, I could technically put my finger underneath that at that point, and that's where it would balance on my finger because it's the balancing point. So we're going to do the same thing for number 4. Why don't you take a minute? You're going to start by plotting your points to make your triangle. Forget you have a quiz tomorrow. Yeah, there's a quiz tomorrow. There's a quiz review in the rainbow card that you can grab if you were absent yesterday. I am. Yeah. There's not this math. It's just like the little review from yesterday. Like there's one problem on centroids, not this kind of problem, but like the problems we did yesterday that were very easy. There's one in center and there's one circumcenter. It's only 3 questions, but each question has like 5 points. So it's just like it's just like fun to say. Like it's one picture. Instead of me printing out like 20 freaking triangles, we're just using the same triangle for multiple problems. And then that way you get like some of them correct versus some of them wrong. Like they each count as their own. So you're gonna start once you have your picture. You're gonna start by finding the midpoint of any of the sides. I would do CD first just because the order of the letters would make your life easier. Don't make it harder than it needs to be. So use CD first, then you can do DE, and then CE would be the first and the last. So take a minute. So when you find the midpoint, it should realistically fall on the triangle, but you have to also, like you just drew a triangle, so it might be just a little off. That's okay. So see if you can find the midpoints. Realistically, you don't need to do enough for them. If you want to, you totally can.
Can I have this?
You can use it.
Why did it have these things?
I don't know. I don't like that one. Do you want a normal one?
I can have yours.
I have one right here. It's like, these things are old.
Shut up. All right, I'm not gonna be- Hey, you don't use real. It's 25 is the time with doctors. Oh, I did, bro. You joke. I'm doing
You should be adding the X's together, adding the Y's together. You should not be adding an X and a Y together. Those can't go together. X with X, Y with Y. It's here, do your math. Mateo, turn around.
That's a good one. Bring deep fast. No, I'm really hearing you.
Did anybody get the midpoint for CD?
Oh,
It is 4, 2. Perfect. So you're gonna plot 4, 2, and it's gonna connect to the opposite vertice. What the heck? Wait a minute. I caught a point wrong.
It doesn't fit.
Wait, Susie?
Oh my gosh, thank you. It's -4. I'm listening to Carter. It's -4, 2. If it doesn't fall on the line, like red flag. Okay, so it's -4, +2. That makes way more sense. Ah, that's nice. Okay, so that's gonna connect, which makes sense because it's C to D. It's the midpoint of CD, not over there. So it's -4, 2. It's gonna connect. It's gonna connect to the opposite vertice, which is E. What's the midpoint for DE? 5, -1. So we're gonna plot that. That should fall in the middle of DE. 5, -1. Wow, these are really turning out perfect this time. So then I'm gonna connect that to the opposite vertice. The opposite vertice is C. And then the last one, CE, should be what? Does anybody get the point?
Oh, -1.
-1. And then
Oh my.
this is -8 divided by 2 is -4. So -1, -4. So that's going to connect to the opposite, which is D, where they crisscross, where the 3 lines crisscross. That is the centroid. And I know the graph is a little ugly because I feel like the X and Y axis aren't dark enough. Can anybody see what that is? That like 0, -1. So this is easy, right? So we're not going to do the next problem because we don't need a million examples of these, right? Do we feel fine? We feel okay? Yeah, we're chilling. So cross out 5, you don't gotta do that. On the back, I also don't want you to spend a bunch of time on this because, you know, we don't gotta do that. So on the back, you're gonna cross out 1 and 2. Yep, so cross out 5 on the front. On the back, we're going to cross out 1 and 2. Just because I don't want you to spend a million years doing these. You do have 2 problems, okay? You have 3 and 4. But we're going to pause here, put it to the side. You will have time at the end of class to work on this, but we're going to finish the Orthocenter papers real quick. And then you guys can just work on this stuff. So the only problems you're doing is 3 and 4. You're crossing out everything else. So pause wherever you're at. We're going to find our paper that has our cute little diagrams on it.
Oh, I still have that.
Okay.
In there.
Find your diagrams. We're going to finish Orthocenter.
Really?
Orthocenter, we are not doing any math with. We're literally just going to fill in our little.
Right.
So we're going to fill in our little Orthocenter. Then we're going to move along with our lives. So we are going to add something to the centroid. The centroid, what we just talked about, is probably the most important out of all of the centers. Orthocenter is definitely the least important. So the centroid, underneath where it says centroid, I want you to add a little star. And this is your balance point. For the graphs. Orthocenter is what we're going to finish up. Orthocenter does not involve any math. The reason why is because on this picture, you have no tick marks. You have no angle marks. There is literally nothing going on here except for the right triangles. So the only thing you can do with this, you can't match any pieces. It's not a puzzle. There's nothing that matches. You can't move any numbers. Literally the only type of math problems that you can do with this is literally Pythagorean theorem problems over and over and over again. So we don't do that. It's like a waste of time. So we're just going to talk about it. We're going to discuss it. We're going to discuss what it looks like, and then we're going to move on. So for an orthocenter, this is created by altitudes. Oh, hold on. Where's my red? So it's made by altitudes, which is technically the height of something. So like when you're in a plane, they say we're currently at an altitude of 10,000, blah, 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 because it represents height. So an orthocenter is created by a vertex connected to the opposite side so that it is perpendicular to that side. Perpendicular means it's creating a right angle because it's the height going straight down, making a right angle. So it represents your height, kind of like at the doctor's office, like you're standing straight up. That's why it's perpendicular to the ground. And it just represents your total height. And that's it. That's all we're going to write because there's nothing else to write because there's nothing else about it that we need to know. So we're officially done with this paper. Let's move on to our orthocenter paper and keep on moving and keep on grooving.
Look at them.
So this is 58. We're going to do 6.7 orthocenter. So what is an altitude? An altitude is a segment that joins a vertex. So this is your vertex. Boop, boop, vertex. To the opposite side so that it is perpendicular to that side. So it goes straight down, making a right angle. Sometimes your altitude or your height can be, and we actually did this a little bit in the beginning of the year when we did area of 2D shapes. Sometimes the height is going to be represented on the outside of the shape, the inside of the shape. Sometimes it's going to be on the shape. So for this one, this is your vertex. That's the point at the tippity top. And if I go straight down, that perpendicular thing is going to go right here, boop, and then I put my little right angle. If I look at the last triangle, this if I look at my vertex and I go straight down, this would represent a right triangle. So sometimes it's on the triangle, sometimes it's in the triangle, sometimes it's a little Akko taco because your vertex is here and it goes straight down and you're like, well, why is the height outside of the triangle? That can happen. So instead of using a regular line, we're going to use a dashed line. 1, 2, 3, little boop, boop, boop. So it represents the height on the outside. All of these technically represent H, which is like the height, the altitude of the triangle. It just depends if it's an obtuse triangle, the height's going to be on the outside. If it's a acute triangle, it's going to be on the inside. And if it's a right triangle, it's going to be on the triangle. Okay, so an orthocenter has 3 altitudes. Where the altitudes crisscross at the center is called the orthocenter. So if I look at this picture, one of the altitudes is BF. That is one of the altitudes. What would be another altitude in this picture?
DP.
D, not DP,
Wait.
BC.
not BC, A to E. And then D is one of them, but where does it have to go fully? C, because it's got to go all the way across. Where those 3 altitudes crisscross is the orthocenter. So at what point do they cross? Point B, because it's the center. Point B. And that's it. That's all we're going to talk about. So the next part is just reviewing all the different centers. So a circumcenter is created by the intersection of what 3 lines? Look at the poster.
Altitude.
No. That's an orthocenter.
Angle bisector.
No. Circumcenter?
Perpendicular.
Perpendicular bisectors.
Perpendicular. That's like this.
It's not. Look at the poster. They're not even the same color. There's
Same color. It's like.
they do look the same. That's the whole point. They're not the same. They look the same.
Wait, they actually look.
The in center is made by what? Angle bisectors. This is also on your diagram paper that you just filled out. The centroid, which is what we talked about yesterday, is made by what? Look at the poster. The median. Context clues. The orthocenter is the last one. That's created by altitudes. And then down here, it has 2 important pieces of information, which is why we're going to do constructions tomorrow, only of these 2. Tomorrow, we're going to do constructions. So a circumcenter is equidistant to the vertices. So it's equidistant to the vertices. And that's why on that poster and even on your little diagram paper, we highlighted the hypotenuses of each of the triangles. So from the center to each vertice, each corner, those are all congruent. The next one is equidistant to the sides. So that's going to be your in center. Tomorrow, we're going to use like the compasses to make these crazies. So the last one is an in center and they are equidistant from the side. So in center. Okay, so all we have to do is look at all these pictures and determine which center is being shown. So let's look at numero uno.
Angle bisector.
It is angle bisectors, but that's not the center. What's the center called if it's an angle bisector?
Median.
No,
Circumcenter.
no. Look at
Angle
the
bisector.
in center.
Oh, wait.
Oh.
Anything with angles is automatically in center. That's the only one you deal with angles. This one has no congruency marks, just right angles.
Orthocenter.
Orthocenter.
Oh, I think. Oh, it's a little bit.
The next one has tick marks on the outside,
Centroid.
the centroid. It's not circumcenter because circumcenter also has right angles. These are not right angles. So centroid and circumcenter are very similar, but they're not right angles for the centroid. The next one is a circumcenter. Let's do number 5, and then you can try the last one. So now it's showing less and less, but based on what's shown, what is in the picture?
I think you have a student.
Okay.
Centroid.
Not centroid. Nope. Wait, perpendicular. That's not even right.
Wait, orthocenter.
The circumcenter? Because the hypotenuses are congruent.
Oh, I see.
Okay, take a second, try the last 5. They're not going to show every single marking, so you have to look at what they're giving you. So try the last 5.
Wait, what's the,
Because your map.
is the next one Centroid?
Yes.
Next one is a centroid, yeah.
Like, please don't tell me this is back.
The back is like yesterday. It's not Orthocenter
I
map,
didn't
it's
do it.
centroid.
Oh,
Oh,
No,
well,
wait, no, I did. That was like the only day I did.
yeah, it was really easy. That's what the back is. The back is really easy.
No, I don't look around. I had a illness.
I had an illness. Is that what you said?
Feel breeze.
You said an illness. Okay, what's number 6? Centroid. What is this one? Shh.
Circumcenter.
No,
That's in center.
in center. Because the Y on the inside is congruent, so the heights are congruent. What's 8? Nope.
Orthocenter.
Ortho. The next one is angles in center. And last but not least,
Circumcenter.
circumcenter. So on the back is a review of yesterday's. Yesterday's was very simple. We all flew through it.
Oh, I know.
We can do one of them together if you want, and then you have the 2 questions on the other paper and then the back side of this paper. This back side will not take you long unless you weren't here. But on the back side, let's do number 5, just because. So take a second, put number 5. We're going to put our numbers on our picture. If you want to split your numbers like we did yesterday, you can. I'm just going to put the numbers on here.
Are you taking pictures?
Mateo, turn around.
He's taking pictures, but you wouldn't know that if you weren't. Well, it's good that I turned around, so now I know that he's taking pictures. And he's sending them. Yo, I did it. No, I'm giving you back.
Stop. I'm gonna have to split up the boys again, each corner of the number.
It's just, because you're good at that. Oh, my. Oh, no.
Yeah.
Oh, no.
So if this piece is 23, we'll start with the small piece. How much is the bigger piece on the other side?
23. Like 220.
2 23s, which technically is 46. You could put 23 twice, like we did yesterday. I'm just gonna put 46 for today. The big piece over here is 44. So how much is the small piece? 22. Now, 54 is the whole line. So what did we do yesterday with that?
You divide.
Divide by 3. How much is each piece?
18.
18. So this should be 18,
The other one, 36.
and the other one is
Yeah.
36. So you're going to fill in your numbers. What we did yesterday was it's split into thirds, technically. The bigger piece is 2. The smaller piece is 1 of them. So F to M is 22. A to F is 66.
What's it, 36?
CM is 36. ME is 18. MB is 46. And DB total is
69.
69. You're doing the rest of these. Okay. And then you have 2 problems on the other paper. Whichever one you want to work on first, you're going to take a picture of both and put them online. Yep. Hold on, what did you say? You can cross out 1 and 2 at the top.